Okay, so I'm going to run through the problems on 3.2 just to help you out. Here you go. So the first one we're going to take and we're going to FOIL it out. So first, outer, inner, last. We collect like terms. We recognize that negative I squared is negative 1, or I squared is negative 1, so this becomes this. Collect like terms again. A equals 0, 10 equals negative 10. So that's how that one should be done. All right, so if I want to get rid of an I on a bottom, a single I, so this could be separate, multiply top and bottom by I. All right, so that gives me negative 4I plus 4I squared all over 5I squared. All the I squareds become negative 1, so this is negative 4I minus 4 over minus 5. Now I'm going to distribute and rearrange. So this part right here is going to be 4 over 5I plus 4 over 5 for this part right here. This is put the real part first and then the imaginary part. So this should be 4/5 and this should be 4/5. So that's what it's looking for there. All right. You have to, before you can do anything with the negative square root, you have to put the I first. That changes everything. So this is negative 9I, square root of 441I. So this is the square root of 9, which is 3, I squared. The square root of 441, I think, is 21. Let me grab my calculator and make sure I am remembering that correctly. You can't see my calculator on this program, but I have it right next to me now. So second square root, 441 is 21. So this is 3I squared times 21. 3 times 21 is 63, and I squared is negative 1. So this is going to be negative 63. So the real part is negative 63, and the imaginary part is 0. This guy right here, you're going to have square root of 3I over square root of 3I. Again, it's important that you don't do anything with the square roots until after you take care of the negative in it. This is undefined. You can't work with that. This is well defined. You can work with this. Those are going to cancel out. So this is I over 2I squared. And this is I over negative 2. So the real part is 0. And this is negative 1/2 I. And B is negative 1/2. Right. Multiply this by a conjugate. So this conjugate is this. Change the sign in the middle in front of the I term. Multiply it out, FOIL it out. We know conjugates multiply out to the difference of 2 squares. So it's going to be negative 2 squared minus 5I squared, which is 4 minus 25I squared. A lot of people will do the I squared and forget to do the 5, so just keep that in mind. So that's 4 plus 25, which is 29, so this should be 29 and 0. No matter what number they give you here, this guy has to be 0, because that's why we multiply the conjugate, is to cancel out the imaginary term. Moving on, 6. Right, we have 8I, 32I. Let's keep in mind now we have, this is 8 is 2 root 2 I. This is what, 2, it's 16 times 2, so 4 root 2. 2 root 2, not 8. I. So this is going to be 8 times square root of 2 times the square root of 2, which is 2 times I squared. 16i squared, which is negative 16. All right. Return the indicated operation and multiply. Express the answers in terms of I as a complex number. So this is just negative 28i squared. And that will be negative 28 times negative 1. So that's just going to be 28. You might try 28. If that doesn't work, try 28 plus 0i. They might want it in full complex form. All right? Because that's why it says express the answers. Why don't I just pause real check how they want that answer. I did check, and they just want it as a whole number. 28 works just fine. So this would be 81i squared, which is negative 81. And they want it just as negative 81. This is 45i minus 20i squared, which we are going to want to put this in order. So here I'm going to take that as negative 1, so positive 20 plus 45i. So this should be 20 plus 45i. And then double check, type that in and make sure that they take that answer okay. Yes, that works out exactly how they would want it. All right, so this is a triple FOIL. I'm going to FOIL two things, simplify, FOIL that it does not matter which order I FOIL these things in. So I'll just go from left to right. Does not matter. I could do the first two, I could do the first and last, it's not going to matter. This multiplication is commutative. So we can do it any order we want. I'm just going to do it this order. All right, so I get 10 minus 6i. That's the 2's. Now the 1's is plus 5i, then minus 3i squared. So that's a plus 3. So it's 13 minus I. And now I'm going to multiply this to the 3 plus 4i. So that's 39 minus 3i. 4 times 13, 4 times 12 is 48. Add 4 more is 52. So plus 52i. And then minus 4i squared. So this right here is 49. So 49i. And that is plus 4. So 39 plus 4 is 43. So 43 plus 49i. All right. Perform the indicated operation. So I get 40, negative 40, minus 48i, minus 50i, minus 60i squared. So that's a plus 60, because that's negative 1. So 6 plus 60 minus 40 is 20. And then gathering these like terms, that's minus 98i. Okay, FOIL this out. It's just like in algebra, you have to FOIL it out. You can't just like square the first and square the last. So FOILing it out, you have the first thing squared, plus 2 times the first thing times the last thing, plus the last thing squared. 64, 16 times 11 is 176. Plus 121i. Squared. So 121 minus 62. Difference is going to be 59, so negative 59 plus 176i. All right, this is the project of its conjugate. conjugate is just the difference in the middle. When you have this, you have the difference of two squares, so 49 minus 36i squared. Again, this should not have any I terms. That's why we use conjugates. So this would be 85. Now you're getting into this division, which is why we need the conjugates. So what I'm going to do here is multiply the top and bottom by the conjugate of this. So my bottom is going to be 81 minus 121i squared. My top is going to be this number, which I need to multiply out. So let's take a look at that. So 132 times 9. $11.88, and that's that term. And then the next term is 9 times 94, negative 846i, and then 132 times 11 plus 452i, and then 94 times 11, 1,000 minus 1,034i squared. Right? So 1,088 plus 1,034 equals 2,222. And 1,452 minus 846 equals 606. So that's plus 606i. All over on the bottom, we have 81 plus 121, 202. Now we can see if these reduce. This one is 11, and 606 divided by 202 is obviously 3, so it ends up being 11 plus 3i. So there we go. And okay. I need to erase this a little bit because see the new problem. I wrote over it. All right, 44 divided by I. Get rid of the I on the bottom, multiply top and bottom by I. Negative 44 over I times I squared. Sorry. Which is negative 1. Which is 44i. So 44 divided by I is 4i. All right. So we just want to convert this. 1 plus 7i minus 4 times negative 1 plus 5 times negative I plus I to the fourth is just 1, right? So this is 1 plus 7i plus 4 minus 5i plus 2. Collect like terms. That's 2i. 4, 6, 7. 7 plus 2i. I think these are all very similar to everything we've done, so hopefully this will give you a pretty good start on how to go from here. If this isn't helpful, please let me know. Send me another email, and I will get right back to you. Thanks. Bye.